All right, so we're going to look at a few things about the first part of our electricity and magnetic unit. So electrostatics charge, we're mostly talking about Coulomb's law. So the thing with this one is, besides the basic Coulomb's law equation, which I'll point out to when we come to it, is you got to remember that the fundamental charge in electricity is the charge on an electron, okay? So which is 1.6 times 10 to the negative 19 joules. That means that you can't have a charge that doesn't equal some ratio of that. So if I have, you have to be able to divide that number into whatever charge you have, and it comes out as a whole number. So that's kind of the thing to remember with this. And then the other thing to remember is that everything in chemistry or physics or anything is always about balance. So everything has to equal each other on both sides of the aisle. So let's go through, I'll just do a few of these problems that should get you through the whole electrostatics part. The diagram below represents two electrically charged, identical sized metal spheres, A and B. One of them is 2 times 10 to the negative 7 coulombs. One of them is 1 times 10 to the negative coulombs. So this one has, and they're positively charged. This one has more positive charge on this side, which means that if they come in contact with each other, they're going to figure out a way of being the same. They want to reach equilibrium. All right, so if the sphere is brought into contact, which sphere will gain a net charge of electrons? So that means that a net charge of electrons means that you're going to gain negative charge, okay? So if you look at this, if you put them into contact with each other, essentially you can just add them together and divide by 2, and that's going to be the new charge on them. So whatever has the most positive charge is going to get the most negative charge in order to get in between. So this is I would assume, I'm not going to do the math in this, but I assume it's going to be 1.5 times 10 to the negative coulombs if you brought them in charge. That would be the average between the two, okay? So that means that I have to add some negatives to side A in order to get it to reach that point. Okay, so that's all it's really asking is just think of it as a teeter-totter. Everything in chemistry, everything in physics has to be at equilibrium. All right, let's see. A metal sphere A has a charge of negative 2 units, and an identical metal sphere B has a charge of negative 4 units. If the spheres are brought into contact with each other and then separated, the charge on sphere B will be, and again, what we're looking at is we want them to be at equilibrium. So if A is 2 negative and B is 4 negative and they touch each other, they're going to want to be an average, so 3 negative, right? Essentially, the easiest way to do this is just add them together and divide by 2. Now, this changes if you have things like different sizes and things like that, but that's really all we're asking here is when do they reach equilibrium? If an object has a net negative charge of 4 coulombs, the object possesses how many electrons? Well, remember what our fundamental charge is. 1.6 times 10 to the negative 19 coulombs per electron. That means that every electron has that many coulombs. So all I have to do if I want to figure this out is I just take 4 coulombs and I divide that by 1.6 e to the negative 19, 2.5 times 10. Ooh, look at that. 2.5 times 10 to the negative 19 you know. Now, what is this saying? All I really want to do is I want to take 4 coulombs. I'm going to divide that by 1.6 times 10 to the negative 19 coulombs per electron. And this tells me, because coulombs goes away, this tells me how many electrons will I have. And because I want negative charge in that case, it means that I'm going to have more electrons than protons, because we're talking about net negative charge, and electrons are negative, right? All right. I'm going to skip that part. Let's go over here. Oil droplets may gain electrical charges as they are projected through a nozzle. Which quantity of charge is not possible on an oil droplet? Fundamental charge, 1.6 times 10 to the negative 19. Which of these can you not divide this into and get a whole number? 2.6 divided by 1.6, nope. 3.2 divided by 1.6, yep. 4.8 divided by 1.6, yep. 8 divided by 1.6, yep. And now all you do is just take 8 divided by 1.6, and it's a whole number. You can't divide 1.6 times 10 to the negative 19. Who cares about that part? All I'm going to do is 2.6 divided by 1.6. That does not equal a whole number. So that's all we're really asking. So the answer is number 4. Okay. Let's see. When the test charge is released, which it will move towards what? Okay, a positive test charge, that's what I have right here, is placed between an electron, where's the electron? An electron E and a proton P, as shown in the diagram. So this is my electron. And remember, the electron is negative, and my proton is positive. So this test charge is negative. Is it going to be attracted to the positive, or is it going to be attracted to the negative? Well, it's definitely going to be attracted towards the negative side, so it's going to go towards D. All right, how are we doing on time here? 6 minutes, we're flying. Okay, a metal sphere has a net negative charge of 1.1 times 10 to the negative 6 coulombs. So I have a big sphere. It's 1.1 times 10 to the negative 6 coulombs. And we want to know how many electrons. Again, remember that the fundamental charge is 1.6 times 10 to the negative 19 coulombs per electron. So if you take coulombs divided by coulombs, that means the coulombs goes away, electron pops up there. This tells you how many electrons are going to be in there. So let's try that. 1.1 to the 6, 1.16 negative divided by 1.6 e to the 119 negative, 6.875 times 10 to the 12th, which I think is this one number right here. Okay, so do the math on that and you can see what's happening. All they're doing is, remember, the fundamental charge, you've got to be able to divide that into whatever charge you have, and it tells you how many electrons there are. Let's see, I won't do any more on this one. A positively charged glass rod attracts object X. The net charge on object X, okay, so I have a glass rod here, okay, and it's positively charged. Okay, now here's the weird thing about this. So I have X over here, and it's attracted. So X has to be either one of two things. It has to be negative. You know, that's a given. But here's a weird thing. It also could be 0. It may be 0 or negative. It turns out that if I have X and it's 0, it means it has plus and negative charge. Okay, otherwise it wouldn't be 0. Well, those negatives are actually going to be attracted to the positives. So don't think that the only thing that can be attracted to a positive charge is something that's negative. It also can have something that has positive charge also. And so in this case, it's going to be maybe 0 or negative. Because in order to be 0, it has to have positive and negatives. The negatives will be attracted. Okay, last one we'll do. The charge to mass ratio of an electron is, okay, and so look, if you don't know what the equation is, they're telling you. The equation is coulombs divided by kilograms. So that means I have to take the coulombs of a kilogram, 1.6 times 10 to the negative 19 coulombs, and I have to divide it by the kilograms of an electron. Both of these are in your booklet. You'll be able to get that when you're doing the IB test. The mass of an electron is 9.11 times 10 to the negative 31 kilograms. Look at that, kilograms per, so we'll do the math really quick. 1.6 e to the 19 negative divided by 9.11 e to the 31 negative equals 1.17563111745. Probably put that in scientific. 1.76 times 10 to the 9th. Do we have that? I don't have that. Hold on. Not working out the way I want, so I know it's going to be. Wait a minute. Are these two numbers the same? 1.76 times 10 to the negative 11. Oh, 11? It's either this one or this one. Try this again. 1.6 e to the 19 negative divided by 9.11 e to the 31 negative equals, oh yeah, there, I just did the math wrong. 1.76 times 10 to the 11th. Okay, so if you do the math right and you don't screw up on your calculator, you're going to get this number. But the cool thing about this is they gave you the equation. You take your charge on an electron divided by the mass of an electron, gives you the answer.